Hello everyone. In the previous video, we saw a general procedure about how to go ahead with a substitution method. So we learned only the type 1 procedure there. So based on that type 1 problems, if we do, it would be easier. So simultaneous, like knowing the concept and doing the problem would be simultaneous means easy learning would be happening. So that's it. On that basis only, I've prepared this video. So we would be doing a problems based on substitution method. So what we have seen just now. We saw that if it is in linear format, like ax plus b format, in that case, how my integration is going to be proceeded and how I would be getting that solution, like based on formulas I've written this side towards my right hand side. I've mentioned all that. Even you guys can have a check with that. So based on that, we would be doing no need to remember this formula. You would be knowing how this formula we have like proved it. So if you have not kindly looked into that particular video, you would be able to learn it. Based on that, we would be doing these problems. Let me start with the first question which is being given. So here they want me to integrate 2x minus 3 whole to the power 5 plus 1 by 7x minus 5 whole cube plus 1 divided by root of 5x minus 4 plus 1 divided by 2 minus 3x plus root of 3x plus 2 dx. Wow, a very big five-term problem has been given. The term means I'm splitting it based on this one actually. How I'm splitting it, let me just tell you. I'm taking this one. One, two, three, four, five. These five things I need to integrate now. Let me make it super quick for you. So, based on the formula, what we learned, this one, the first term, what we have 2x minus 3, it comes under the formula. Um, this one, ax plus b whole to the power n. And then we have one logarithmic one that is going to be our fourth one. It comes under logarithmic one. The all the other things, I think it comes under the first one itself. So these are the two integration identity which I'm gonna use now. So let me start doing the problem. So we have integral 2x minus 3 whole to the power 5 dx. I'm gonna write it separately, splitting it so that my calculation would be super fast. So it's gonna be 7x minus 5 whole cube dx and then plus integral 5x minus 4 whole to the power minus half dx, and then I have integral 1 by 2 minus 3x dx plus one last term, it's gonna be 3x plus 2 whole to the power half dx. Now let's proceed. So the first one, what we have here, let me consider I is equal to everything. So here I is equal to, if I put everything is equal to I. So now here I would be having 2x minus 3 whole to the power 5 plus 1 divided by 5 plus 1, which is nothing but 6, but into 2, the coefficient of x I need to divide 1. Okay, so next one plus I would be having 7x minus 5 divided by, okay, first let me complete. It's gonna be 3. It's not just 3, it's minus 3. So minus 3 plus 1 is gonna be minus 2. Here I would be having 1 by 7, that is 7 in the denominator, into minus 2. And then plus I would be having 5x minus 4 whole to the power minus half plus 1 is going to be half divided by 5 into half, which is 5 by 2. And then we have plus ln of, okay, I would be having ln of 2 minus 3x. And what's the coefficient of my x is minus 3. So into 1 by minus 3. And then the last one plus I would be having 3x plus 2 whole to the power half plus 1 is going to be 3 by 2. And here the coefficient of x is 3. So it's going to be 1 by 3. So 3 into 3 by 2. So I think we have done with all the integration now, just multiplying and then writing them as a term. So if I do that, I would be getting I is equal to 2x minus 3 whole to the power 6 divided by 12. This is going to be the first one integration answer. And then minus 1 by 14. 7x minus 5 whole to the power minus 2. And then we have 5 by 2. 2 is in the denominator's denominator. Obviously, it would take the place of the numerator. So it would be 2 by 5. 5x minus 4. I can write it as root of. That would be the best option. So it's gonna be 5x root of 5x minus 4. And then we have minus 1 by 3 ln of 2 minus 3x. And then plus we have the denominator as 9 by 2 and 2 is there in the denominator's denominator. Obviously, it will come to the numerator. It's gonna be 3x plus 2 whole to the power 3 by 2 plus c. So that's it. We are done with our integration with the very first problem which we have taken. Now let's see. If we know this formula, actually if we are doing using substitution, how we would be doing it. Okay, this part of the problem. See actually how lengthy it becomes. Let's see that. So now here, in this problem, I would be considering each and every term as we are separating, for each and every term we would be considering. Let 2x minus 3 be equal to t. Then when I differentiate both the sides with respect to x, I get 2 dx is equal to dt. So obviously dx is equal to dt by 2. This is how I would be doing it for each and everything. Then I would be like finishing the integration a little bit slow. So this becomes faster if you know this procedure. That's the reason I thought of this procedure for you. Now let's proceed with the second problem. A quite easy problem. Second one, just like that, by looking at it, you can tell the answer. It's going to be 2x minus 3 dx. Since we are aware about this, how it works, it's going to be 1 by a e to the power ax plus b plus c. So here I observe that I have I is equal to integral e to the power 2x minus 3. So when I integrate it, I would be getting it as e to the power 2x minus 3 as it is. But what's the coefficient of x? 2. So it would be getting divided by 2. That is nothing but multiplying by 1 by 2 plus c. So this is gonna be my answer for this. Now, next question, we have integral a raised to the power of 3x plus 2 dx. So in this case, let me consider this to be equal to I. So in that, what we have learned here for a to the power x, integral a to the power x dx is equal to a to the power x divided by log base e of a plus c. This was a standard form like previously what we have done. But now we are not having just a, we have a raised to the power of 3x plus 2. We are not having just x, we are having in a linear format. In that case, I would be getting 1 by 3 into a to the power 3x plus 2 divided by log base e of a plus e. That's gonna be my answer. So here I would be writing it as 1 by 3 log base e of a. And you can write here as a to the power 3x plus 2 plus c. That's it. It gets over. Now let's look into few more problems. I think you guys are able to understand. If you have any kind of trouble with it, kindly comment it in a chat, this one, so that I would be able to have a check and reply to you back. So now here, the next question goes something like this. Secant square 7 minus 4x dx. So now here, what happens? What is the integration of secant square? Integration of secant square is tan x plus c. Right. So now here let me consider I is equal to, but I don't have just x. I have 7 minus 4x. And what's the coefficient of my x is minus 4. That's something very important. So when I integrate, I would be getting minus 1 by 4 would be getting multiplied along with tan of 7 minus 4x plus c. whatever be the coefficient of x, that person, negative or positive, that would be getting multiplied in a reciprocal way. Means minus 4 means it's gonna be minus 1 by 4. That's how it would be getting multiplied. Or I can say that it gets divided by my integration result, whatever I get. So it gets divided with tan of 7 minus 4x divided by minus 4. That's how it works. Now let me go with the next question. So fifth one, we have 1 divided by, let me change my color back. Fifth one, we have 1 divided by sine square x cos square x dx. We have something like this. So I would be considering this to be I is equal to. Now what I would be doing here, sine square x cos square x I have. So now let's try in a different approach. I think this is a very normal problem. It's no way related with my substitution. Okay, let's have a check with that. One, I'm going to replace it by sine square x plus cos square x divided by sine square x cos square x dx. So in this case, I would be getting sine square x divided by sine square x cos square x dx plus cos square x divided by sine square x cos square x dx. Cos square, sine square gets cancelled. I get integral 1 by cos square is nothing but secant square x dx. This one was just a normal integration, nothing big, like a substitution one. I don't know why it got mixed up. I'm sorry about it. But 1 by sine square is nothing but cosecant square x dx. I think this type of problem we have already done in previous video. Integral secant square x. What is that gonna be equal to? It's gonna be equal to tan. So I'm gonna write that as a tan x and then minus cot x plus c. So that's what we have done here. Like based on for see here, we have secant square ax plus b, but what the problem was a little bit simpler here. If I could have changed it as ax plus b, then it would have been like a little bit of substitution work, which we would have done. Okay, anyhow, let me go with the next problem where we have substitution now. I'm sorry about this problem. Now, sixth one, we have integral cosecant square 3x plus 2 dx. Okay, it is in the format of ax plus b here. Obviously, now we would be able to do here as we wanted. Like cosecant square of x dx. What is the integration of that? It's nothing but minus cot x plus c. Now here I would be having minus cot of 3x plus 2 plus c, but something else I need to do because I find the coefficient of x is 3, I need to multiply by its reciprocal. So minus 1 by 3. So your answer is gonna be like minus 1 by 3 cot of 3x plus 2 plus c. And then let's move on with the next one. Let me do it here. Seventh one, we have integral sine of ax plus b and then cos of ax plus b dx. Wow. And we know something interesting about one of the trigonometric identity. If you observe, we have sine 2x is equal to 2 sine x cos x. Just observe this term with my question. We have this one. What is missing? 2 is missing. I can bring that by introducing like multiplying and dividing by 2. So here in this question, let me consider this as I is equal to multiply and divide by 2. In that case, I would be getting I is equal to 1 by 2 into 2 times sine of ax plus b and then cos of ax plus b. Now I got it just like my identity. 2 sine like this. What is that equal to? It's gonna be half of integral sine 2 times I have ax plus b dx. Now I would be able to go ahead and integrate it without any trouble. So what I would be having here is half of integration of sine 2 times ax plus b is nothing but 1 by, sorry, just a minute. Okay, here I would be having 1 by, let minus 1 by 2a cos of, obviously, see, 2 is there. So 2 times ax plus b plus c. So now here I would be getting minus 1 by 4a cos of 2ax plus 2b plus c. This 2 which is there, obviously this 2 would be getting multiplied with both the terms. That's the reason here I'm not only getting a coefficient as a, but I'm getting a coefficient as 2a. That's the reason I'm dividing by 2a. Hope you understood. Or else, let me just show it to you what exactly happens there so that you would be getting a clarity about it. So see here, when I have half of integral sine of 2 times ax plus b dx, this is nothing but half of integral sine 2ax plus 2b dx. Now, when I go ahead and integrate sine, obviously I would be getting negative. So negative cos of 2ax plus 2b. But what is the coefficient of x is 2a. So I need to multiply by its reciprocal 1 by 2a. So plus 6. So now this 1 by 2a gets multiplied with the half which I have. So which is already minus 1 divided by 4a cos of 2ax plus 2b plus c. This is how it happens. Hope you understood. And let me continue with the next video with the different approach of substitution. Okay. Thank you guys.